So here we go, getting started with our explain the theory of continental drift. Just breaking this down, reminder that a theory is an idea based on evidence, right? Because we don't have a personal account to 100% connect this idea. We need to have evidence to back it up. So this idea of continental drift is thinking about what is going on with the land, the continents that we can see. And drift, of course, is how they move, right? So what do we know about the movement of land over time based on evidence that we can see today? And this theory is coming to us from this German scientist known as Alfred Wegener. He did a lot of climate research. He did a lot of travel. He collected a lot of the data and started to put them together into these maps. And the maps are what we use to connect a lot of those evidences today. So you can start filling in the blanks there on the left side, using the details that we're talking through. And then reminder, every once in a while we'll pop over to that right side to answer a few questions or label some things. So Alfred Wegener came up with this idea based on these evidences that he noticed while mapping everything out. Starting with one we've seen a lot in the past week is this idea of fit of the continents, thinking about the shape, or some of you have said like the edges or the outlines, the coast, right? That's what we're thinking about here. And what's cool, what I like about this one is obviously on this big map, we can see there's similarities between these coastlines here that we have highlighted, but the picture I gave you on your notes is this one, right? So there's really two parts to every piece of land. There is the continent that we can see, but there's also this part right here called the continental shelf. It's an extension of the land, the continent, but that part is underwater. So that's something we can't really see. You can see it a little bit in this map here, right? It's something we don't see because it's underwater, but being a map maker, that was part of the details that were included. And so when we look at that continental shelf, we can see just how tight these do really fit together. So even more of a fit than what we see on the surface with our eyes. So filling in the blanks there, on the left, we want to make sure we know the idea here. Fit of continents has to do with the coastlines, right? They fit together like a puzzle piece. And two major ones are South America and Africa. Now, there's other continents that appear to fit together as well, but these were the ones that really set the theory going, really got things started. Fossil B, again, thinking about a lot this week with our puzzle idea. We're thinking about how these like areas of fossils match up really well with other locations, right? We're seeing that if these fossils exist from one location to the next, we know that those two locations at one point had to be together. There's no way those plants and animals could have traveled across the ocean, especially when we think about something like this guy, right? The fern. It could not, in our current location of all the continents, have made its way to these 6 major locations with them all separated the way that we see them. So it just reminds us to have multiple places with that same organism. They all would have had to have the exact same climate, the all same environment. Therefore, they all had to be connected at one point. And so again, putting the continents together like a puzzle, we are recreating that once all land piece. So that's our second evidence of fossils. Evidence C is looking at that same idea, matching things up, but this time rocks and mountain ranges, right? We don't think about it, but rocks have a specific makeup. almost like people have a DNA, right? So you might be looking at two rocks that just look like pieces of the earth to you, but when you break it down, they all have a certain percentage of minerals that they contain. And so this mountain range here that runs across our North American continent is the same exact genetics, if you will, of this mountain range running across Europe. And so again, that gives us a clue that this at one time was connected together, allowing for that, again, kind of puzzle piece recreation, saying that they had to be the same place and therefore exist at the same time or form at the same time because of their specific details. So that includes mountain ranges like these exact features, but also the rock type and their age match up across continents. So if you did want to label something on your diagram here, you can make yourself a note like that these would have the same age and, like we said, genetics. Our final piece of evidence is climate, and before we get our blanks filled in on the left, let's start by looking at the picture there on the right. So what we're seeing is a map of several continents that we know today, and some evidence of what their rock record shows about climate. So here we're looking at our North American continent. We see green, meaning it used to be tropical, or it shows that record of tropicalness in this area. It also shows coral reefs and those coal swamps. We're seeing that same pattern across Europe, tip of Africa and South America. We're also seeing polar evidence, all this blue, and glacial striations. That means glacial scratches, essentially, across all these locations: Australia, India, Antarctica, Africa, and South America. So what this map is showing is that the rocks in those areas are telling us that's what the climate was. Okay? So when we think about the question on the right, Africa in particular, Africa is showing evidence of polar in its past. Is that the kind of climate you think about of having in Africa today? So you should be able to circle your thoughts there. And hopefully your connection is no, right? We think about a lot of desert and heat there in Africa. Definitely not glaciers existing there today. So what does that mean about where Africa used to be in the past? Where on earth did Africa have to exist in order for glaciers to be something that rock shows us, or that continent was a part of? So think about the earth, where we typically find that type of climate, and what does that mean about Africa's past location? So pause if you need to and get that idea recorded there on the right. So as we think about what that means for Africa, let's just get our details in here about climate. Like we said, tropical evidence is now recorded in places that are near the poles, and polar evidence is recorded in places that are now near the equator, like Africa, right? Being close to the equator, Africa doesn't have possibility of polar climate today. But it tells me that it wasn't always near the equator. It had to be somewhere else where polar evidence was possible. So it's a clue that these continents have moved over time. For instance, like we're seeing in this map, Africa and India had to be somewhere further south, closer to the pole, allowing them to have that polar climate recorded in the rock. And they've since moved locations to have a very different climate exist today. So overall, we have those 4 pieces of evidence from Alfred Wegener. He hypothesized, using those evidences, that everything used to be connected together. So per our discussion, the idea is that all those evidences had to connect. So he recreated the supercontinent called Pangaea from his maps and approximated its time frame around 200 million years ago. So Pangaea, what that means is a fancy way of saying all land. So he used those evidence to reconstruct the supercontinent. Here's kind of a modern day take on Pangaea. We can see all the countries that we know today and the orientation it would have looked like then. Thinking about all of this being ocean, nothing on the essentially the backside of the earth right now. So he came out with all this information, and it was a pretty wild idea, saying that the earth moved, like that it changed. It didn't just exist this way always forever. His hiccup, I mean, people took in the evidence, people understood his 4 major evidences, but where his theory failed essentially is he didn't have enough evidence or information to explain how the continents actually moved across the earth. This is a big thing in your notes to star, circle, highlight, underline that part of the notes. What his thinking is that the continental crust essentially drifted across the oceanic crust, similar to how like an Arctic boat would cut through ice. It just plowed its way through. But what we know and what we knew then about the continental compared to oceanic crust, even though it's thicker, it's less dense, so it's not as strong. So there's no physical way for that continental crust to be able to cut through that oceanic crust. So even though all of his evidences worked to say, hey, these had to be connected at one point in time, there was no part of his theory that worked to explain how they actually moved. So again, if you haven't yet, star, circle, highlight that main point there so you don't forget that big idea. He couldn't explain the motion part. So even with all those strong evidences, his idea was initially rejected, and he never was able to see the full acceptance of this idea of continental drift, because obviously it's still partly valid because we're talking about it today, but evidence would come out later to add to Wegener's theory, because most of it was right. Most of those evidence pieces work still today. But we have a new theory now, this final idea of the theory of plate tectonics. And that ties in the motion of the plates, which he could not fully explain. So you've got all your details over here on the left. The notes are done. We answered the question above. You've got one final right-hand side question here. Where else could we look, right? Wegener, at this point, his ideas are stalled out. Where else are we looking on Earth, or what other ideas might you have to start thinking about additional evidences that we know today that we can start tying it in? So get at least one bullet point down here. And then you're headed over to your study guide, thinking about learning target number 1. Looks like this. Just a quick reminder, with learning targets, we're thinking about a couple things. Wherever you see these describes, reminder, we're thinking about full sentences. So that means you're taking the question, incorporating it into your answer, so it's not just 1 or 2 words, right? So starting with part of the question, like maybe continental drift theory states continent locations have, and then give that big idea. Same thing down here, another describe how those 4 evidences are used. So again, pulling the question into the answer. 4 evidences for continental drift support the theory because what do we do with the evidence? How are they used in the theory? Okay, and as always, you've got 2 keywords from me to make sure that get into part of your descriptions here. So you are using them and then highlighting them in your writing. right? So I'm looking for those highlights in your writing. You don't have to highlight these. I know you need to use them. I'm looking for them somewhere in your writing, okay? So my recommendation is always go side by side with your notes, because that's where all the answers are coming from. This is not a Google search assignment, right? It's coming from our notes, from our activities, pulling the ideas together and putting them into your own words. As always, message with any questions you have.